You ever see a headline that screams about a new study being statistically significant? It sounds so official, so final, right? But what does it actually mean? Well, today we're going to pull back the curtain on this incredibly powerful and, let's be honest, often completely misunderstood idea.
And this quote, man, it just nails the core issue, doesn't it? Are we using data to genuinely light up the world and find the truth? Or are we just kind of stumbling around in the dark looking for any post we can lean on that happens to support what we already believe? That's really the central question we're diving into here.
And here it is. Meet the main character of our story. This little expression, p is less than 0.05, has become this incredibly powerful gatekeeper in science. For decades, it's pretty much decided what research gets published, what new drugs get approved, and even which ideas we as a society consider to be true. So how on earth did one little number get so much power? Well, that power has, in many ways, become a kind of tyranny. The relentless hunt for this magic number has actually started to warp the scientific process itself. Let's dig into how that happens.
So you've got this bright line rule, right? And it creates a huge problem, something researchers call the file drawer problem. Just imagine all the perfectly good studies that find, well, nothing. Their p-value comes back at, say, 0.06. What happens? They often get stuffed away in a file drawer, literally never seeing the light of day. And the result of that? The science that we do see, the published stuff, becomes super biased. It paints a picture of a world that's just full of exciting effects that might not be nearly as strong or maybe even as real as we're led to believe.
But, the problem isn't just the file drawer. It's that a whole lot of us, and yeah, even some scientists, have a fundamental misunderstanding of what a p-value is actually telling us in the first place.
Okay, and this is where things get a little mind-bending, but stick with me. We all want the p-value to be simple. We want it to tell us the chance that our big idea is wrong, but it just doesn't. What it actually tells you is the probability of seeing your specific data, assuming that your theory is totally false to begin with, what statisticians call the null hypothesis. Think of it like a smoke detector. A low p-value is like the alarm blaring. It's the probability of the alarm going off, assuming there is no fire. If that probability is super, super low, you start to think, maybe there really is a fire. But here's the key. The alarm itself never tells you the exact probability that there is a fire. And that distinction, while subtle, is absolutely crucial. This whole thing got so out of hand, in fact, that the American Statistical Association, which is a pretty big deal, issued this unprecedented warning to the entire scientific community. And their points really get to the heart of the mistakes we all make. First, don't base everything on just crossing that 0.05 finish line. A significant result could totally be a fluke, and a non-significant one doesn't mean there's no effect there. Maybe your study was just too small to find it. But maybe the biggest one? A p-value tells you absolutely nothing about whether the result actually matters in the real world. So what we've done is we've taken this tool that was meant for nuance, and we basically turned it into a sledgehammer. Science is supposed to be the slow, careful process of gathering evidence. But this simple binary thinking, significant versus not significant, it creates this dangerous, false sense of certainty. It sorts all of science into these two piles, worthy and unworthy. And that has massive, real-world consequences. But hey, it's not all doom and gloom. The good news is that statisticians are really leading the charge to move beyond this rigid black and white thinking. There is a better way forward. And it all starts with a fundamental shift in philosophy. Instead of chasing this impossible goal of absolute certainty, we need to embrace a whole new mindset. And it's really captured by these 4 simple ideas. We need to accept uncertainty, and be thoughtful, open, and modest. And that first one, accept uncertainty, that's the big one. It's the whole ballgame, really. Science isn't about finding the one final definitive answer. It's about skillfully navigating a world of uncertainty. We have to let go of this false promise that a single number can ever give us a final verdict. So, what does a more thoughtful approach actually look like in practice? Let's take a look at a really cool alternative called Bayesian inference. This table just lays it out so clearly. On one side, you have the old way, the p-value test. It asks a really simple yes or no question. Is there an effect? But look at the Bayesian approach. It asks a much better question. How much evidence is there? So with that p-value of 0.26, all we can really say is this clunky phrase, we failed to reject the null. But the Bayesian method, it can actually tell us that the null model, the idea that there's no effect, is almost twice as favored by the data. It lets us find evidence for the absence of an effect, which is something a p-value can never, ever do.
And that is the absolute key. We're moving away from this courtroom model where every study comes in and delivers a final, dramatic verdict of guilty or not guilty. Instead, we're moving towards a scientific conversation where every single study adds a new piece of evidence to be weighed, to be debated, and to be discussed. That is how we actually build a more accurate, more nuanced understanding of the world.
Now, this isn't just some dusty academic debate, right? The way we choose to use statistics has profound ethical implications for all of us. I mean, think about it. A flawed study could lead to a terrible new education policy or an ineffective, expensive medical treatment. The stakes are really high.
So let's bring it back to our lamppost. The term data-driven sounds good, but it can be really dangerous. It almost implies that data is forcing our hand, and it often becomes a tool for support, a way to justify a decision we secretly wanted to make all along. A much healthier, much more ethical approach is to be data-informed. Here, we're using data for illumination, to genuinely understand a complex situation better, and that includes understanding what our data can't tell us.
And of course, when we get obsessed with just finding that one significant result, it can encourage some really bad behavior. I love this term, p-hacking. It's where you basically torture your data, running test after test until it finally confesses to a p-value under 0.05. Or you just cherry-pick the results that look good and ignore the rest. These aren't just innocent little mistakes. They are serious ethical missteps that completely distort our shared understanding of the world.
So, from now on, the next time you see that phrase statistically significant, just pause for a second. Ask yourself this question: is this new information truly lighting the way to a deeper understanding? Or is it just another lamppost being used for a little bit of support in the dark? The answer to that question, well, it tells us pretty much everything we need to know. And it's a question we should all be asking a lot more often.